Oh my gosh, what is this? What is flashing across the screen? This is an almost guaranteed test question, just like the guy in Gold Rush guarantees everything every week. Yes, I guarantee that you will almost likely see this question on the boards. Why is that? It's because the boards love this test question. Now, I would pay close attention if I were you for at least the next few minutes. Now, this is actually the most common human enzyme defect, and it's going to be X-linked recessive. Alright, so glucose 6-phosphate dehydrogenase is going to be involved in both the HMP shunt and the respiratory burst. Now, it's going to play a key role in regenerating NADPHs. So we start off with an NADP, and we're going to make an NADPH via this enzyme here. Alright, NADPHs can then prevent oxidative damage, so they can help reduce an oxidized form of glutathione, which yields a reduced glutathione, and that can go on to neutralize hydrogen peroxide to prevent further damage. Alright, one of the main problems in G6PD deficiency is that this prevents reduction of glutathione, which makes cells more susceptible to oxidative stress. Under normal conditions, most patients might not have any symptoms, but when subjected to oxidative stress through things such as drugs like sulfonamides, primaquine, isoniazid, you may also see like fava beans, their red blood cells aren't going to be able to handle it, and they'll lyse, causing a hemolytic anemia. Now, these patients should also not eat those fava beans since they contain high levels of oxidants. The only silver lining here is that G6PD is going to provide some resistance to malaria, possibly because of the higher oxidative stress. Therefore, G6PD deficiency is more common in black people. How will you be tested on this G6PD? One way that boards love to present this is by showing a slide depicting these bite cells. Bite cells, which are indicative of G6PD deficiency, are red blood cells that have bites taken off of it. Now, why in the heck would a phagocyte bite off parts of a red blood cell? In G6PD, the NADPH serves as a protective antioxidant role to the red blood cell. I am trying to drive that point home to you right now. If you're not able to produce this NADPH, you aren't able to generate the reduced form of glutathione, which is going to be protective to the cell from hydrogen peroxide damage. Now, here we're going to see a Heinz body. When you can't protect the cell, you get oxidized hemoglobin, and that oxidized hemoglobin precipitate within the cell into a Heinz body. You see these Heinz bodies here. Alright, so we've got a phagocyte here. They're going to come along, they're going to eat these Heinz bodies, and then thus you get a bite cell. So phagocytes are going to recognize these Heinz bodies inside the red blood cell. They're going to bite off pieces of that cell trying to get to these Heinz body accumulations. Now, if you see Heinz body or bite cell on test day, you need to immediately think, is this G6PD, and is it possibly an NADPH deficiency? Alright, now let's move over to the disorder of fructose metabolism. How does fructose, a monosaccharide carbohydrate, fit into the grand picture of metabolism? Fructose metabolism is important because it converts into a substrate for glycolysis and thus energy production. Now, as you can see here, fructose enters the glycolysis pathway partway through, and that's going to be at the level of the G3P, the glyceraldehyde 3-phosphate. Normally, it's converted into fructose 1-phosphate by fructokinase enzyme in the liver. The enzyme aldolase B then converts the fructose 1-phosphate to dihydroacetone phosphate in glyceraldehydes. The triose kinase can then combine these two to make G3P, which is one of the substrates in glycolysis. Now, essential fructosuria is an autosomal recessive defect in fructokinase. If you're missing fructokinase, what happens? Let's say you're missing this enzyme here. Fructokinase is the enzyme that phosphorylates fructose after it enters a cell. And if this phosphorylation that prevents the fructose from then recrossing the cell membrane and leaving the cell is missing, so there's nothing keeping the fructose within the cell, so it just washes out into the urine. Therefore, this is a benign and asymptomatic disease. However, fructose intolerance is a more serious autosomal recessive disorder of the enzyme aldolase B here. Notice how we're color-coded. So fructose intolerance relates to an aldolase B deficiency. Without aldolase B, fructose 1-phosphate here accumulates. Since it's already been phosphorylated, it can't leave the cell. Now this consumes a lot of available phosphates, which is going to inhibit glyconeogenesis and gluconeogenesis, two processes that require large amounts of phosphate to operate. So we're using up all of our phosphate stores to phosphorylate fructose to trap it in the cell, but once it's trapped in the cell, it has nowhere to go. It can't get broken down further. Without glycogenolysis, or the breakdown of stored glycogen, or gluconeogenesis, which is the formation of new glucose, fructose intolerance causes hypoglycemia, or low blood glucose levels. Will you see large amounts of glucose on urine dipstick in a patient with fructose intolerance? That's the question that I posed to you. I would say no, because the urine dipstick is sensitive for glucose only. In fructose intolerance, patients will have detectable amounts of reducing sugars in the urine, but the sugars are not going to be glucose. Patients will also have jaundice, cirrhosis, and vomiting due to the toxic accumulation of the fructose 1-phosphate within the liver. Now, the treatment for this is to not eat fructose, or sucrose, which, since sucrose is a disaccharide composed of both fructose and glucose. Now, in general, disorders of galactose metabolism, which we'll discuss next, are going to be more serious than disorders of fructose metabolism. Quick question for you. Is essential fructosuria or fructose intolerance more symptomatic, and why? Give you a second to think about it. 50-50 chance. Take a guess, and hopefully you guessed fructose intolerance. Fructose intolerance is worse since you have a deficiency in aldolase B. Remember, that's the enzyme in fructose intolerance. Since you don't have aldolase B, you lead to a fructose 1-phosphate accumulation in the cell. This leads to a depletion of phosphate stores. The body loves its phosphate, so inadequate phosphate stores will inhibit glycogenolysis and gluconeogenesis, which will ultimately lead to hypoglycemia. You're not able to break down glycogen, or you're not able to create more glucose, will lead to decreased glucose levels. Fancy word for that is hypoglycemia.